Alright, this video is a continuation of logarithms. Now we're talking about properties of logs, how we work with them algebraically. So I have 5 properties of logarithms here for us to do. The first one is that multiplication inside logs can be split into adding separate logs. So if you have something like this where you have log b of m times n, you can split that into 2 separate logs by changing and putting an add in here. This is going to be log base b of m plus the log base b of n. So we take the 1 log and we write it as 2. So now here's an example of that. What if I have log base 5 of 4 and log base 5 of 3? Well, because they both have a 5 for their base, we can combine them together with multiplication. This is log base 5 of 4 times 3, and 4 times 3 is 12. Alright, so the next rule is that if we have division inside the logs, that can be split into subtracting. So we can subtract 2 separate logs. So now we have a m on top and an n on bottom. We're going to split those up, and it's the one on top, log base b of m, minus the one on bottom. So my general rule is the one on top, the log base b of m, minus the log base b of n. So now, here's an example. If I have these 2 separate logs and I want to put them together, because there's a subtraction, I know I can make division. And because it has a 6 and a base 6, I know that these 2 will go together. So I combine this into 1 log, and I have log base 6 of 20 divided by 5, which is 4. Okay. Next rule. The third rule is that exponents inside the logs become coefficients in front. So if you have an exponent up here like this, log base b of m to the power p, with p for power, that p can move out front and become a coefficient. We write it like this. The p that used to be small is now a coefficient in front. So now here's an example that goes the other way around. I have 3 times the log of 2. Alright, well since I have a 3 multiplied out front, that 3 can become an exponent. So that becomes the log of 2 to the third. And 2 to the third is 8. Remember, when there's no base shown, then we can assume it's in base 10. Alright, the next rule is that logs and exponents cancel. So they cancel if they have the same base. So if you have something like log base b of b to the x, well, because we have a log base b and then this is a b as well, they cancel out, and the answer to this is just x. And the same thing here. If b has been raised to the power of log b, well, the base down here and the log also cancel out, and this also equals x. So now in this example, log base 2 of 32, well 32 is actually a power of 2. I can rewrite this using 32 to be 2 to the 5th power. Now, because the exponent, I was able to rewrite this using a base of 2, the 2's and the 2 here will cancel out, and the answer is just 5. Alright, one more rule. If you take the log of both sides, okay, or you have a log on both sides that has the same base, of the entire side, not just a part of it, of the entire side, well then that whole log cancels. Here I have a log base b of x and log base b of y. Well, because the log is the same there, it cancels out. This is just equal to x equals y. Or in this example, here I have log base 2 of 7x, but I also have a log 2 on this side. Since I have log 2's on both sides, they cancel, and I can just work with the part inside the logs. So 7x equals x squared plus 12. Okay, we have a quadratic here, don't we? An x squared. So this is what we learned last unit. Do you still remember how to do this? Subtract the 7x over so it equals 0. Okay, now we have to factorize this. And in order to factorize, we learned box factoring. So I'm just going to come to the side really quick and not going to really walk through. I'm just going to show you a quick box factoring. So it looks like this factors into x minus 3 times x minus 4. And when we set each part equal to 0, we're going to say x minus 3 equals 0 and get x equals 3, and x minus 4 equals 0 and get x equals 4. Alright, let's do a couple more examples. Okay, so for the work today, what I want you to be able to do when you leave class today is I would like you to be able to take long expressions like this that have multiple logs in them and simplify them into, condense them into one log, or to take something that has only one log and expand it out into as many parts as you can. So first of all, let's simplify this one. Okay? So first off, when I'm simplifying, I'm looking at those three rules really. The one about the adding turning to multiplying, the one about subtracting turning to dividing, and looking for multiplying in front to become exponents. So I look at this. Okay, I see a 3 in here first. Let's get rid of that first. This 3 that's multiplying, I can change that to be an exponent. And I'm going to go ahead and take that 3 and move it up to make it an exponent. Alright, now I have addition here first. So I'm just moving from left to right now as I solve. I have a log 4 plus a log 2 to the 3. So, and they have the same base of a 2, so I can use this adding is going to turn to multiplying. So I'm going to put these together to be one log base 2. And I'm going to multiply the 4 times the 2 to the 3. Okay, well, 4 times 2 to the 3. 2 to the 3 is 8. 4 times 8 is 32. Alright, so now I have log 2 32 minus log 2 8, and I have a subtraction. Well, with subtraction, I know that subtraction can turn into division. So I'm going to have the first number divided by the second number, and it combines into being only one log. And 32 divided by 8 gives me 4 for my final answer. So the original one simplifies down into log 2 4. Alright, let's see if we can make this one longer. Expand it out. Okay, the first thing I want to do is get rid of this division. Now I know that division changes to subtraction, so I have the thing on the top subtracting the thing on the bottom. So I can split this up into two logs. Log 2x squared y for the top minus another log for the bottom. Okay, so now I have three things that have been multiplied together here. I have a 2 times the x squared times the y. So since these are all multiplied, I can change my multiplication to addition. So I'm going to make each of these adding and put a separate log for each one. So I'm getting ready to put 3 logs down here. So first I have log 2, then I've got, okay, and then the same thing on this side. I have a log 3, and the 3 is multiplied to the k to the third. So I can break this multiplication up into addition as well by adding another log. So, and as I do that, let's go ahead and do that. Let's see if I have enough room. So I'm going to break the log 3 times k cubed up into log 3 plus log k3. Alright, and copy the rest the same. Okay, I'm almost done. Now the last step is, I have 2 places where I have an exponent. This exponent of 2 can be written into the front as a coefficient of 2. And this 3 can also come to the front as a coefficient of 3. And I'm going to go ahead and distribute this negative out here to both the log 3 and make this a negative here. Negative in front of this log k. So I'm going to bring my exponents down, and I'm going to distribute my negative for my last step, final answer. Okay, so this part's the same. I took this 2 out in front to make it here, and then I took this negative and distributed it to both parts, and then I took the 3 from up here and brought it down in front. Okay, so that is the final answer. That is expanded to be very long.